Alright, this is the first part of the Chapter 6 practice test. Learning target A. I can differentiate between endo and exothermic reactions. Well, an endothermic reaction, that means if we have a system and we have a surroundings, that means energy is going from the surroundings into the system. And remember, we're always looking from the system's point of view. So that means we will be adding energy to the system. So it absorbs heat and has a positive value for delta H. Always look from the system's point of view. Letter B, I can apply Hess's law. So Hess's law is where you're given two or more equations and you use those to find the enthalpy for a goal reaction. So here are our two equations. We want to manipulate those to look like this equation right here. So start right here. Find PCl5. Notice I have a PCl5 here, but I have 4 of them. So let's take this reaction and divide it by 4. That means 4 PCl5 divided by 4 would be 1, just what I want. Arrow, and then I would have 1/4 P4, because I'm dividing by 4, plus 10/4 Cl2. Since I divided it by 4, that means I will have to take the enthalpy and divide that by 4. So I will have 3,438 kilojoules divided by 4 as my enthalpy for this reaction. The next species that I want to find is PCl3, and you'll notice I have PCl3 on the correct side of the reaction, except I have 4 of them here. So I'm going to take this reaction once again, and I'm going to divide it by 4. And so I'm going to rewrite it over here as 1/4 P4 plus 6/4 Cl2 arrow, then divide this by 4, and I will have 4 divided by 4, or 1 PCl3, which is exactly what I'm looking for, 1 PCl3 right here. So now I've made the correct number of that. Since I did that, I'll also take my enthalpy and divide 2,439, notice it's negative, and divide that by 4 as well, and that would be the enthalpy for this reaction. Now to find the overall reaction, I still need some Cl2s, but you'll notice if I have 6/4 Cl2 on this side of the arrow and 10/4 Cl2 on this side of the reaction, some of those will cancel off. As a matter of fact, 6/4 will cancel off for both of them, and I will have 4/4 remaining. So I'm going to combine these two reactions by adding them, and that means all the things on this side of the reaction then go together. I'm going to rewrite it right down here. And I would have 1/4 P4, and I would have 6/4 Cl2, and I would have 4/4 PCl5, and then everything on this side of the reaction would go right over here. So I would have 4/4 PCl3 plus 1/4 P4 plus 10/4 Cl2. And now anything that's the same on this side, I could cancel with anything on the same as this side. And so the 1/4 P4 goes away. The 6/4 Cl2 goes away with 6/4 of this, and 10 minus 6 is 4, so I end up with 4/4 Cl2 remaining, which would be 1 Cl2. And then I have 4/4 PCl5 and 4/4 PCl3, and of course since 4 divided by 4 is always 1, I end up with my goal reaction of PCl5, arrow goes to PCl3, plus Cl2. Now, since I have my goal reaction to find the enthalpy, since I added the two reactions, I add the two enthalpies. And if you take negative 2,439 divided by 4 plus positive 3,438 divided by 4, you will end up with 249.8 kilojoules as the overall enthalpy. This manipulation of these reactions is what is Hess's law. Let's do the second one, 1.3. Find the delta H for the reaction below, giving the following reactions and subsequent delta H values. So here's my goal reaction right here on the top. And now I need to manipulate these three reactions to end up getting this goal reaction. So I'll start from the way here on the left-hand side. I need two CO2s. Two CO2s are in the bottom reaction, but they happen to be in the wrong side. So I'm going to flip this reaction around, and I'll write it as 2CO2 plus 3H2O, arrow, C6H6 plus 7/2 O2. And when I do that, I need to flip the sign of the delta H. So now the H becomes positive 283 kilojoules. Notice when you reverse the reaction, you reverse the sign of the enthalpy. Next, I need some waters. I can see that I have waters in this reaction and this reaction. So let's just wait a second with that one because it's going to be too confusing to just manipulate one of them. So let's go to the other side and let's find a C2H2. And once again, I find C2H2 in the first reaction here, but it's on the wrong side. And so I'll take this reaction and flip it around as well. So when I do this reaction in reverse, I'll end up with C2H6 arrow. Try to keep your arrows lined up so you can be organized. And then that goes to C2H2 plus 2H2. And then the enthalpy for this reaction ends up being the opposite, not negative 94.5, but 94.5, a positive value. Since I reversed the reaction, I reversed the enthalpy. So far, I've got the 2CO2 that I needed for a goal reaction, and I've got the C2H2, which I need for a goal reaction. All right. Lastly, I got to make sure that I get my waters and my 5/2 O2s figured out. And you can see that I have a half an O2 here and a 7/2 of an O2 right here. And if those remain on opposite sides, I'd end up with 6/2 O2, which is pretty close. And then if I multiplied this one by 2, I'd end up with, well, 2/2, and then I could cancel those out, and I'd end up with 5/2 over 2. Now, the same thing would happen with my waters right here. You notice how I've got one water right here, and I've got 3 waters right here. Now, all these reactions are reversed right here, so I'm going to take this second reaction, reverse it, and multiply it by 2, because then I can get the oxygens to cancel, because I'll put the oxygens from here on the other side, because you'll notice they're on the product side right here, and I'll get the H2Os on the right hand side, and I can get 2 of those to cancel with these, so I end up with just 1 H2O. So I'm going to double this reaction right here, and if I double this reaction, I'll also have to double the enthalpy, and then don't forget when I flip it around, I'm also going to have to make this be negative. So this one would be 2H2, remember I'm doubling it, plus O2, arrow, keeping the arrows lined up, and then that goes to 2H2O. And then my enthalpy for that would be 2 times 71.2, and don't forget it's going to have to be negative now since I flipped that around. All right, adding these reactions together then, I get all of these species on the left-hand side, all of these species on the right-hand side. And before I rewrite this one, now since we're a little bit more experienced with it, I'm going to do the canceling. So you'll notice the O2 would go away, and I'd end up with not 7/2 O2 here, but 5/2 O2. So 5/2 O2 I'd end up with on this side. And then you'll notice that I have 2 H2Os right here, and that would cancel with 2 of them here, and so I'd just end up with an H2O on this side. And then the other species that would end up canceling out are my 2H2 right here and my 2H2 right here. And then the last thing, oh, I think I wrote this first, let's see, this CO2 reaction, H2O, this is supposed to be C2H6. I think I wrote that wrong, C2H6 right here. So that means the C2H6 right here and the C2H6 would cancel out with one another. And my remaining things would be 2CO2 from right here, my H2O remaining right here, my C2H2 right here, and my 5/2 O2. And now look, I've got my goal reaction. Okay, I've manipulated this to get my goal reaction, and now since I can add the reactions to get that, I would take these enthalpies and add them together. Careful of your sign, careful of your sign. Don't forget to multiply by 2, and remember that's negative, and you should end up with positive 235 kilojoules. One more Hess's Law problem in this video. This is 1.4. Find the delta H for the reaction below, giving the following reactions and subsequent delta H values. So here's the goal reaction right here. And then here are 3 reactions that I can manipulate. And so let's start with N2H2. And it looks like the only place I have N2H2 is in the first reaction. So let's keep that one the same. I'm not even going to rewrite it. I'm just going to leave it there because it's the correct number. H2, it looks like I have some H2s right here and also H2s right here. Since they're in 2 reactions and I only need 2 of them, somehow they've got to cancel out. But let's just wait with that and let's look at the 2NH3. So the only place where I have NH3 is in the second reaction, and there's 2 of them right here. So it looks like I'm going to leave that reaction the same as well because I want to end up with 2 NH3s on this side. So these first 2 reactions I'm going to leave alone. Then this third reaction must be one to help me do some canceling. So I can see that I'm going to want to cancel some H2s from right here because you'll notice I have only 1 H2 in here. And I only have 1 here, so if I multiply this reaction by 2, I'd end up with 2 H2s on this side canceling with those. I'd end up with this CH4O right here. It looks like I have CH4 on this side of the reaction as well. And I have a CH2O. Oh, it looks like I should probably flip this reaction around. So then I could get the CH4Os to cancel and the CH2Os to cancel with each other. And then notice I also have these 3 H2s right here, which would cancel with these. So really what I need is on the left hand side 1 H2. And if I take this reaction and reverse it, then I would have it. So let's write the reverse of this reaction as H2 plus CH2O arrow, and then I put CH4O on here, and my enthalpy now would be positive 65. That takes care of this reaction because I reversed it. And now let's see what I have on this side of the reaction right here. Rewriting everything on this side and rewriting everything on this side. Remember, I canceled these out, so don't rewrite these. I can see that a few things will cancel. First of all, my CH2Os will cancel. You'll see that my 3 H2s will cancel with my 3 H2s. My CH4O will cancel with my CH4O. And then remaining, I have the N2H4. I have the H2, which is right here. Excuse me. I have the, let's see, an H2 right here. And then I have an arrow right here. Oh, I forgot to cancel the N2 with the N2 right here. That's nice that those go away. The only thing left then is this 2NH3 from this particular reaction. So after the canceling and after manipulating this reaction by flipping around, I will get my goal reaction by adding those together, which means I've got to add these 2 enthalpies with this enthalpy. And when I'm done, I should end up with negative 18 kilojoules. That's the first part of the practice test.